morning, everybody. Oh, are you happy today? Yes, I hope that you are all happy. I'm also happy. So let's start our battle. Now, in, in this era, we are using electricity in a wide range of applications. So, we are going to deal with the electricity as most important electromagnetism. I'm starting with the topic electromagnetism. So before that, what is your chapter's name, you know? It's electric charges and fields. Before entering to the main topic, I have to introduce some terms to you. The first is electromagnetism. Electromagnetism is the branch of physics which deals with the electric as well as magnetic fields, its effects and its peculiarities, characteristics and behavior of some materials within electric and magnetic fields, etc. Again, electromagnetism is divided into two types. They are electrostatics and electrodynamics. See, the word electro means charge. It's a Greek word and its root meaning is charge. Static is also come from Greek and the word meaning of statics is at rest. So, in electrostatics, we are dealing with the charge at rest. Then obviously, what is the other one? It deals with the charges moving or moving charges. Charges in motion. Okay. The intrinsic property of charge gives an account that charge is natural. Each and every object in the universe possesses charge. You know the types of charges, where it is present. Yeah, you said the correct answer. It is present in atoms. What are the charges? Electrons and protons. You know, all the objects in the universe possess electrons and as well as protons. So, this is intrinsic in nature or it is natural. Then the second characteristic it is, I already said that two types. What are they? Positive and negative. Then a set of two positive charge and a set of two negative charge. We call this as like charges. Like charges and a set of one positive charge, set of one negative charge. It is called as unlike charge. Then like charges repels each other and unlike charges attracts each other. I think that you studied it in your earlier classes. Then normally we uses these two letters, capital and small letter q, to indicate the charge. And the SI unit of charge is called as Coulomb. It is named after the scientist Coulomb. Either you write all letters in small or you can write a simple capital letter C. This is the indication of charge and its SI unit. Then the next topic is conductors and insulators. Why you call some materials as conductor and some insulators? You know, we have already studied in older definition. The conductors possess free electrons. Conductor possess free electrons, whereas in insulators bounded electrons are present. See, free electrons are present in valence shell, right? When they gain some sort of energy, it will break the bonding between nucleus, and it becomes free to move. It will carry energy from one end of the conductor to the other one. A good example of a conductor is silver, copper, etc. They can carry energy forms like electrical energy, heat energy, etc. If we are holding a rod, one end is our hand, in our hand, and the other end we are heating. What happens? Slowly, the end which we held in our hand will get heated up. What is the cause? The electrons carrying heat energy from the other end will flow to there, right? So this is the peculiarity of conductor. And insulators, it is strongly bounded to the nucleus, so we cannot remove easily from the valence shell. Normally, the conductors can have a valency of +3. That is, at most 3 electrons. At most 3 electrons it can leave. I already told that the valence electrons are loosely bounded in conductors, and in insulators it is tightly bounded. Okay, this is the increasing order of conductivity. And in between this space, why I put a blank? Yeah, it is reserved for another material which is called as semiconductor. Why it is called a semiconductor? It acts like an insulator at normal temperature. But when the temperature increases, the semiconductor shows semiconducting properties. The semiconductor shows conducting properties. So this is the order of increasing conductivity. Right. Then the methods of electrification. These are some of the peculiarities of conductors and insulators. Can you see? It's clear? Yes. Right. Then the next is electrification. What do you mean by electrification? If we are giving a neutral material any charge, if we are charging a neutral material, the process of charging, it is called as electrification. So instead of electrification, if I am using the term electrification, you should mind that it's a charging process. All right. Then okay, there are 3 methods to electrification. That is, by these 3 methods, we can make a neutral body into a charged one. How many charges are there? Yeah, 2 types. Okay, first method is by friction. The friction means that when 2 irregular surface brings in a contact, then there will be a frictional force which will produce some sort of heat energy, maybe less or more less sound energy, etc. So some materials while on rubbing can produce charges. Example, glass with the silver. If we are rubbing a glass rod with a piece of silk cloth, silk cloth, the glass rod is loosely bounded. Glass rod possesses loosely bounded electrons. So when they rub together, there is a small amount of heat energy is producing. That heat energy produced is absorbed by the valence electrons in the glass rod, and they break the bonding between nucleus, and they become free. That electrons are caught by the silk cloth. So when glass rod contacts with the silver, silk cloth, the glass rod gets positive charge and this silk gets negative charge. So this is the friction. Okay, you can do one experiment by yourself. Take a plastic scale. I think all of you have a scale. You rub it in your dry hair. The hair should be dry, and suddenly it bring towards the small pieces of paper which is here on a table. You can see that the paper will sticks to the plastic scale. Why it is? On rubbing, the scale gets a charge, and when it brings near to the paper is of opposite charge, so they attracts. That is the reason. And the next is electrification by conduction. The second method is by conduction. So what do you mean by conduction? I already told that it is the carrying of charge from one end to other end. See, I will draw one diagram. Okay, in the first set of conduction, there is one charged sphere and the other one is neutral body. In the second step, we brings this neutral body in touch with the charged sphere. So then the positive charge will flow from the charged body to the neutral one. And simultaneously we separate these two spheres. Both of the spheres will get positive charge. Okay, so this is the method of conduction. You should note that both the spheres should keep in touch. I emphasize this keep in touch because the next method we are going to study is without touch. Okay, there's another diagram. So the third method of electrification is induction. You heard about the induction cooker? You are using, some of you are using in your kitchens, right? The induction cookers are using this principle. See, a charged body brings very close to the neutral body. Not that it is not keeping any contact, any touch. And what happens to this neutral body? We know that in a neutral body, equal number of positive and negative charges are there. And when this positive charged body is bringing near, it pushes the positive charge towards the farther end, right here to here, in this direction. And as a result, the absence of positive charge, or it attracts, these positive charges attracts the negative charge of this body towards it. So negative charges will move in this direction, right? Then in the third step, we are making a ground connection between the earth and this metallic sphere. Okay, so our earth has a special character. It is a electron bank. What is in a bank, what you are doing? You are taking and giving money, right? In such a way, earth is taking electrons and earth is giving electrons if necessary. So this is the importance of grounding. Then here at the farther end, positive charges are present, right? Then while we make a connection between the ground, electrons will flow from ground to the positive charge to neutralize the charge. If there are 3 charges, the ground will give 3 electrons to neutralize. If there are 4 charges, the ground will give 4 electrons. Now it is neutralized. Now the farther end gets neutralized. Then the fourth step is removing the grounding and this glass rod. What will be the remaining charge here? Can you say? What will be the remaining charge? Is it positive? No, so obviously it is negative. So we can make this neutral sphere into negatively charged one. This is the principle that we use in induction cookers. Okay, the next is, see, you can see that in this slide also. First one is making a negative charged rod brings here. It pushes the negative charges to the farther end, and positive charges are at the near end. Then grounding is made. Grounding, the negative charges from the farther end goes to the ground through this wire, and the resulting sphere is positively charged. See, this is opposite to what I draw. Next, we are going to discuss about properties of charge. The first one is charge is a scalar quantity. Okay, charge only possesses its magnitude. It do not give any direction. That is where it is deriving, where it is going. We cannot get an idea from that magnitude of the charge, right? There, it's a scalar quantity. Second one is additive property. Additive property, which means that consider a system of charges. See, there are 4 charges, Q1, Q2, Q3, Q4. All of these are positive charges. Okay, plus positive Q1, Q2, Q3, Q4. The total system of this, total charge of the system can be taken as the individual sum of all the charges. All the small charges, that is Q1 plus, Q2 plus, Q3 plus, Q4. Suppose that one of this charge, say Q4 is negative, then what will be the sum? This is given, Q is equal to Q1 plus, Q2 plus, Q3 plus, is it right? Collectively, we can say that the sum total of these charges, it is Q1 plus, Q2 plus, Q3 plus, is minus Q4. This is the sum total. Okay, the next topic is quantization. Before entering to the quantization, you should know what is quantization. If you are going to one shop to buy one pen, anybody will ask that I need a half pen. Is it? Then what will be the reaction of the shopkeeper? He will think that something is loose. Okay, right. See, pen is available in 1, 2, 3, etc. Right? We cannot buy a 1.5 pen, 2.5 pen, 3.5 pen. Like the same case, charge cannot be in form of half numbers, that is 1.5, 2.5. We cannot divide the charges into 1.5 charge, 2.5, etc. It exists in nature in integral form of fundamental charge, integral multiples of fundamental charge. So what is a fundamental charge? It's nothing but the charge of one electron. The fundamental charge is given, its magnitude is plus or minus 1.6 into 10 raised to minus 19 coulomb. Why this plus or minus occur? Yeah, it is for an electron it is minus, and for positive charges it is, or say for protons it is positive. So a protonic charge we can write it as E plus or P. Then electronic charge we can denote as E minus. So integral multiples of fundamental charges. This is the form of charge existing in nature. So the basic unit of this fundamental charge is known as quantum. You should be very careful about the spelling quantum. Okay, Quantum. Then finally, Coulomb's law. See, description. The Coulomb is a scientist who made more explanations about the electrostatic force existing between two charged bodies. You know one thing? The experiments dealing with the electrostatic forces started from its It's not before 1 year, it's not before 10 years, it is started from before Christ. And the experiment started from the Greek. Okay, then coming to the Coulomb's law. Coulomb states that there exists an electrostatic force which is denoted by F.
Okay.
If there are two charges, Q1 and Q2, there exists a force between them, and if they are separated by a distance r, the electrostatic force between these two charges is directly proportional to the product of their charges Q1 and Q2. Then it's inversely proportional to the distance square of the distance, and he combined to form that equation Q1 Q2 by R square. Then F is equal to change the proportionality sign, he multiplied with a constant, this is K, and Coulomb's law now reads as F is equal to modulus of Q1 Q2 by R square. Why this modulus? You know that two types of charges. If both these charges are negative, there will be one negative sign. So Coulomb force is a scalar quantity. We no need to consider about the sign of the charges. So that's why I put this modulus here. Then in this session, what are all the topics we covered? Can you remember? Do you remember? Yeah, the first is what is a charge and the properties, characteristics of charge. Then the second topic is methods of electrification, friction and conduction, then induction. Then how do they are charging due to charging through friction, conduction, induction, etc. Then the fourth is properties of charge, especially scalar quantity, its additive property and the quantization, etc. Okay, do you have any doubt? I hope that all the concepts are clear. Then thank you.